A very good morning to all of you. So today we'll be explaining and discussing about the experiment 14 we did earlier, which is the analyzing the fluid flow and level control. So we are from group 2A. So me, myself, and Wong Hoe Kiu, and Farhanah, Azmierul, Noorashikin, and also Badrul. So now let's move on to the objective of this experiment. So the objective of experiment 14 is to determine the fluid flow using the PID controller. And the second is to study the effect parameter of proportional, integral, and derivative, known as PID, the component value to the fluid flow and level control. And for the introduction, so in this experiment, we will be focusing on the PID, which is known as the proportional integral derivative. So it is used to control the fluid flow. So PID combines the proportional control with addition, integral, and derivative adjustments, which help the unit automatically to compensate the changes in the system. So there are 3 steps of tuning. The first one is the proportional tuning, and the second is integral tuning, and the last is the derivative tuning. And now let's move on to the theoretical. Okay, so fluid flow and the level control is basically manipulate and calculate based on the mathematical function, which is in the form of algorithms. And so we will see how it works. The PID controllers, it works with a concept where the system detects, when the system detects an error or something that needs to be changed. So the brain, known as a center, we eventually command the system to get a desired setting. And lastly, the system will then be adjusted to the desired parameters over time. So there are 3, the proportional, the mass function is the KB times the V error. So the effect on the control system is that typically the main drive in the control loop, KB reduces a large part of the overall error. So, and the second one is the integral, so which is the Ki times the integral V error dt. So it reduces the final error in the system. So to sum up, even a small error over time produces a drive signal large enough to move the system toward a smaller error. So moving to the last one, which is derivative, so which is about the Kd times the dv error over dt. So it counteracts the Kv and Ki terms when the output changes quickly. So this will reduce the overshoot at ringing, so it has no effect on the final error. So now I will be passing on to the one who explained for the apparatus.
And for the apparatus, we use SM514 PC level flow control, which the picture at the right hand side, and one more is an AQ software to interpolate the graph.
Next, I will explaining the procedure of this experiment. So first step is that the machine and the pump system were turned on. Second step is the DAQ software was launched on the computer and the connect button was selected. Then all the parameters were run by right-clicking the left box of the TK1 software panel, this is the pressure control. So the fourth step is the parameter 2 in the right box of the program panel was scrolled down and the desired pressure was then set using the SV setting value. So next, the heating proportional bands, which is the P, were adjusted to 5 degrees Celsius. Then the I and also the T were set into 5 second and 2 second respectively. So this value will remain constant throughout the experiment. So then step 5 until step 6 were repeated for different values of heating proportional bands, which were 10 degrees Celsius and 15 degrees Celsius. The add step is that the switch was turned on, and then the last step is when the operation was completed, the acquired graph was stored by pressing the software stop button. So this is how we conduct the experiment. So this is the DAQ software. So okay, the left box is show all the parameters was set into the software. So the right side is where we set the PID over here. And then after we set everything on the DSQ, we turned on the switch. Okay. Okay, next will be explained by my team.
Okay, for the result, so this table shows the number of experiments performed with different heat integral time. So we conduct 3 experiments. So the first variable is heating proportional band, which is P, heating integral time I, and heating derivation time. So for heating proportional band, we make it three variable, which is 5 degrees Celsius, 10 degrees Celsius, and 15. And heating integral time and heating derivation time, we make it constant. Okay. So for this figure, it shows the graph of temperature against time when heating proportional band is 5. So as you can see there, at the beginning of the experiment, there has no temperature changes until the experiment was run at about 1 minute and 30 seconds. The temperature rise at about 1 degree Celsius constantly until it reached 6 degrees Celsius, and then the temperature was unstable throughout the experiment. Next. Okay, so for the temperature against time when heating proportional band is 10 degrees Celsius, it's also same at the beginning. There has no temperature changes until the experiment was at 1 minute and 20 seconds. Then the temperature rise at 1 degree Celsius until it reach at 6 degrees Celsius. Then the temperature was unstable again until the experiment was ended. Next. Okay, so for the temperature against times when the heating proportional band is 15 degrees Celsius, the the temperature also was unchanged until it reached at 1 minute. So the temperature again rise constantly 1 degree Celsius. Then there has until it reached 6 degrees Celsius. Then the temperature was unstable again until the experiment ended.
Okay, so I will continue for the discussion. So for this experiment, like my friend has said earlier, we use a tuning method. So the tuning method we use is trial and error to get the best parameter for the setting. So for the second one, the heating proportional band was changed while heating integral and heating derivation time is remains constant. Like my friend said earlier, the heating proportional band we changed from 5, 10, and 15 degrees Celsius, while the heating integral and derivation is 2 seconds and 5 seconds. So number 3 for the graph. From the graph, we can see the temperature changed by 1 degree Celsius from 6 to 7, like my friend has explained earlier. And it takes about 1 minute and a half for the temperature to change for experiment the first, and the second one is about 1 minute and 20 seconds, and the last experiment is about 1 minute. So the final, this result also identical for heating proportional band at 10 degrees Celsius and 15 degrees Celsius. Yes.
So in conclusion, the objectives of this experiment have been achieved. The first one is flow is determined using PID controller, and the second one is effects of parameter setting to the fluid flow and level control are discussed in the session just now. And then each parameter serves a specific purpose in different circumstances based on the system function. Understanding how an operation works is important in either. So I think that's all for this experiment. Thank you.